Calculating the proper branch circuit overcurrent protection for a hot tub involves several steps. Firstly, you need to determine the total load. The provided information specifies 4 motors and a heating element, all operating at 240 volts. The motors draw 4 amps, 8.7 amps, 8.3 amps, and 10 amps respectively. The heating element consumes 5.5 kilowatts. To calculate the total motor load, sum the amperage of each motor. 4 amps plus 8.7 amps plus 8.3 amps plus 10 amps equals 31 amps. Next, calculate the current drawn by the heating element. Divide the power consumption in watts by the voltage. In this case, 5,500 watts divided by 240 volts equals 22.92 amps. The total load is the sum of the motor load and the heating element load. 31 amps plus 22.92 amps equals 53.92 amps. Now let's determine the appropriate branch circuit size and overcurrent protection. Assuming a 240 volt circuit, the branch circuit must be sized to handle the total load of 53.92 amps. A common choice for residential wiring is number 2 NM cable. Number 2 NM cable typically has an ampacity of 90 amps, which is sufficient for the 53.92 amp load. Therefore, using number 2 NM wire is suitable. For overcurrent protection, an 80 amp circuit breaker is often selected. This provides adequate protection for the circuit while allowing for the continuous operation of the hot tub. However, when using an NB cable inside a conduit, the ampacity must be adjusted due to the conduit fill. The National Electrical Code, or NEC, specifies the allowable fill percentage for conduits based on the number of conductors. For 3 conductors, which includes the hot, neutral, and ground wires, the conduit fill is limited to 40%. The ampacity of the number 2 NM cable, which is initially 90 amps, must be derivated by this 40% factor. Multiplying 90 amps by 0.4 gives an adjusted ampacity of 36 amps. Since the total load is 53.92 amps, number 2 NM cable in a conduit is not sufficient because it is only rated for 36 amps after deriving. In this situation, an alternative wiring method is required. One option is to use individual conductors such as number 4 THHN or THWN wire. These conductors have a higher ampacity rating compared to NMB cable when installed in a conduit. Number 4 THHN or THWN wire typically has an ampacity of 55 amps, which is sufficient for the 53.92 amp load. Therefore, if using a conduit, number 4 THHN or THWN wire is a suitable choice. In summary, the total calculated load for the hot tub is 53.92 amps. The branch circuit can be wired with number 2 NM cable and protected by an 80 amp circuit breaker. However, if the wiring is run inside a conduit, number 4 THHN or THWN wire is required to account for the ampacity derivating due to conduit fill. Remember, it is always recommended to consult the latest version of the National Electrical Code, or NEC, for the most up-to-date code requirements and consult with a licensed electrician for proper installation. This information is for educational purposes only and should not be considered a substitute for professional electrical advice. Always prioritize safety and adhere to all applicable electrical codes and regulations. Furthermore, when dealing with electrical systems, it is crucial to understand the various components and their functions. The overcurrent protection device, such as the circuit breaker, is designed to protect the wiring and equipment from damage caused by excessive current flow. It does this by automatically interrupting the circuit when the current exceeds a predetermined level. The ampacity of a wire is the maximum amount of current, in amps, that a conductor can carry continuously without exceeding its temperature rating. It's essential to select a wire with an ampacity that is equal to or greater than the calculated load to prevent overheating and potential fire hazards. The National Electrical Code, or NEC, provides guidelines and tables for determining the appropriate wire size and overcurrent protection based on the load and installation conditions. It's a comprehensive resource that covers various aspects of electrical installations, including wiring methods, grounding, bonding, and safety requirement. When working with electrical systems, always follow safe work practices. To energize the circuit before making any connections or modifications. Use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. Double-check all connections to ensure they are secure and properly taut. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. They have the knowledge, skills, and experience to ensure the job is done safely and correctly. In addition to the wire size and overcurrent protection, it's also important to consider the voltage drop in the circuit. Voltage drop is the decrease in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for limiting voltage drop in branch circuits and feeders. To minimize voltage drop, use larger conductors or shorten the length of the circuit. Grounding is another critical aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and de-energize the circuit. This helps to prevent electrical shock and equipment damage. The NEC specifies the requirements for grounding and bonding electrical systems. Bonding is the connection of metallic parts to form an electrically conductive path. This helps to ensure that all metallic parts are at the same potential, reducing the risk of electrical shock. Surge protection is also an important consideration, especially for sensitive electronic equipment. Surge protective devices, or SPDs, are designed to protect equipment from voltage surges caused by lightning strikes or other electrical disturbances. SPD divert the surge current to ground, preventing it from damaging the equipment. When selecting an SPD, choose one that is rated for the appropriate voltage and surge current level. The installation of electrical equipment should be done in accordance with the manufacturer's instructions and all applicable codes and regulations. Proper installation is essential for ensuring the safety and reliability of the electrical system. Regular inspections and maintenance can help to identify and correct potential problems before they become serious. Look for signs of damage, such as cracked or frayed wires, loose connections, and corroded components. Test the overcurrent protection devices to ensure they are functioning properly. Keep the electrical panels clean and free of obstructions. By following these guidelines, you can help to ensure the safe and reliable operation of your electrical system. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. Remember, electricity is a powerful force that can be dangerous if not handled properly. Take the necessary precautions to protect yourself and others from electrical hazards. And do not be afraid to consult with local inspectors about permitting requirements that you must meet, and be aware of code variations in your local jurisdiction as well. They should be helpful. The NEC code is updated every 3 years, so be sure that the information you are consulting is current. A hot tub is a large load, and safety is paramount.